How do you find the components of a force vector that is parallel and perpendicular to a momentum vector? That's what I have for you today. I'm Ben. This is Physics or Bust. So here's our example. We have an asteroid that makes a close approach to Earth at an instant when the momentum of the asteroid is 3.50 times 10 to the 15th, 6.20 times 10 to the 16th, 0 as the three components for its momentum, kilogram meters per second. The force on the asteroid by Earth is 3.81 times 10 to the 11th, 0 newtons. And we're going to find the parallel and perpendicular force. So with this, our first task is going to be to figure out what p hat is. We're given the full momentum as a vector, but we need to find out what the unit vector in the direction of momentum is. So looking at the formulas here with p hat, you'd have the px over the magnitude of p, py over the magnitude of p, and pz over the magnitude of p. So we need to find the magnitude of p first, and we can do that using the square root of px squared plus py squared plus pz squared. So putting those numbers in, we end up getting 6.21 times 10 to the 16th kilogram meters per second as the magnitude of the momentum. So each component of the momentum then needs divided by that number. So we get 3.5 times 10 to the 15th over 6.21 times 10 to the 16th and 6.20 times 10 to the 16th over 6.21 times 10 to the 16th. So our answer for what p hat is 0.0564, 0.9980. So now that we know what p hat is, we can go into our formula for finding the parallel force. So we have the px times fx plus py times fy plus pz times fc. So when we put in the numbers, we get 0.0564 times 3.81 times 10 to the 11th plus 0.998 times 3.81 times 10 to the 11th plus 0, because nothing was in the z direction. Which gives us an answer of 2.15 times 10 to the 10th for our magnitude of the parallel force. So to get the full vector of the force parallel, we then multiply that by p hat. So we take the 2.15 times 10 to the 10th newtons, and we'll multiply it by each component of p hat, 0.0564 and 0.998 and 0. So our F parallel then is in the x direction 1.21 times 10 to the 9th, in the y direction 2.15 times 10 to the 10th, in the z direction 0. Finding the parallel force at this point is a lot easier than finding this one, because now it's just a matter of taking the original force and subtracting the parallel force. So when subtracting vectors, when you're given all the components, you just subtract the components that are in the same direction. So 3.81 times 10 to the 11th minus the 1.21 times 10 to the 9th, 0 minus the 2.15 times 10 to the 10th, and 0 minus 0, which is just going to be 0. So our perpendicular force then is just 3.80 times 10 to the 11th in the x direction, negative 2.15 times 10 to the 10th in the y direction, and 0 in the z direction. And don't forget to put your units when you're writing these things down, especially as your final answer. If you're needing to learn more about vectors, go ahead and click into this playlist right here, and that'll get you going on some videos that talk about all the details of vectors and their operations you can do with them. Don't forget to like and subscribe, and remember, keep asking questions. I'll see you on the next video.